Okay, so now we come to the last round of this episode. So this problem is so a friend of mine right after test gave me this problem because this problem did not appear in top A test. So he told me this problem. So when you expand and collect the like terms of A plus B plus C plus D plus 1 to n, it has 1 on 1 terms, find n. So I was given this problem and so I need to solve it for him because he's really anxious because he gets the problem. So let's just start with this thing. So it has 1 on 1 terms. So we know that each term should have the form a to the something, a to the x times b to the y times c to the z times d to the t. Times I'll say 1 to the u. So we know that since we want to multiply, we are choosing like each term comes from like choosing a certain number of a's, a certain number of b's, a certain number of c's, d's, and 1's. So we know that these 5 things, x plus y plus z t plus u equals n. So basically each term is different. So the terms are different if only if these 5 numbers are different. So now when we see this, it becomes like a stars and bars problem. So essentially, we want to find the number of quantuples or 5 tuples that add up to n. So the common techniques that we can use to do this is to arrange n objects and 4 bars.
I have a question.
Yes.
X must be what? Positive integer or non-negative?
So according to this interpretation, if there are only 1 on 1 terms, the x, y, z, t, u can like some of them can be 0. So I'm solving the problem right now. This problem right now. So we have n objects, 4 bars. So when we arrange them, we have n plus 4. Choose 4 ways to arrange them. So this should be number of terms, which equal to 1001. So let's expand left and right. Sorry, a little bit. N plus 4, n plus 3, n plus 2, n plus 1 over 24 equals 1001. Okay, so if we're actually solving this equation, it's like a 4th degree polynomial, so we probably don't want to actually solve it. We want to just get some check in some sense. So we know this is 7 times 11 times 13. So we should be looking at something around n equals 12, n equals something between 10 and 14. So we know that this must include 11 and 13, and since 7 is here, we probably need to include 14. So which means that there are 4 consecutive integers. We'll multiply them together equals 11 times 13 times 7 times 24. So we want 7 to be 14, so we write it as 14 times 12. And hey, 12 is right between 11 and 13, so we're good. So we have 11, 12, 13, 14.
So n plus 1 is 11.
So n plus 1 is 11, and equals 10. So I got an answer, and I told my friend, and he said, this is not answer choice. I'm really confused. So, like, say, are you sure? Like, he said, yeah, like.
Especially you have such nice computation, right?
Yeah, like, okay, so I said, do you have the problem statement? So he gave me his AMC10 test. So I see, so I read the prompt, and I realized that he missed something. So each term must contain at least all 4 of A, B, C, and D. Okay, so let's see what this new condition change to our problem. So if they all contain A, B, C, and D, it means that x, y, z, and t are all positive. So
you should write that down.
Yeah, so now we have x, y, z, t are positive. U is still non-negative though. So let's try to so since we already have such a nice result, how do I like change this form to this form? So one easy way is to just subtract 1 from all x, y, z, and t, so that they become non-negative. So which means that we have x minus 1 plus y minus 1 plus z minus 1 plus t minus 1 plus u equals n minus 4. So now it becomes now it just becomes an arrangement of n minus 4 objects and 4 bars. So this becomes n choose 4. Actually, it's nicer. So this becomes n minus 1, n minus 2, n minus 3. So we already find that z is equal to 11, 12, 13, 14 in some order. So n is the largest one, so we have n equals 14.
Yeah, your original equation is n plus 4 choose 4.
Yeah. So essentially the answer increased by 4, simply by including this condition, and there's like not much thing different. And indeed, this is one of the answer choices, so we're happy. And he actually gets this answer correct, so he is also happy. So next time we will continue our discussion on AMC 10A and 12A problems. So see you next episode.
All right, see you then.
See you then. And good luck on AMC B test.
Yeah.